Hi everyone, it's Dr. Christians. In this video, we're just going to go through some of the basic pieces and parts that you need to know about how this spreadsheet's going to work before we dive in and actually start putting together our own version of it and then seeing how to make changes. So this is the baseline case for Pole Cottage. So what this is what's currently installed at Pole Cottage. And I'm going to walk through just some of the basics of how the spreadsheet works, so it's a little bit less information all at once when we actually go to set it up. So what we've tried to do is color code certain areas to help you know what you should change and what you shouldn't change. So this gray color here, those are going to be pieces of information that maybe you want to know, but aren't going to be pieces of information that you are going to edit. We'll look a little bit inside some of these different things, but we're not actually going to change the values. Then this green information here, those are some of the key results from our simulation. So that's the total amount of heat that this home is going to be using, about 2,900 BTU, 29,000 BTUs, or 213 therms per month. Then here in the middle, the pink values, that's going to be where we add, for example, insulation, where we look at the size of our home. Those are going to be mostly where we actually are editing the spreadsheet. To just walk through a couple of the key features, we can look over here how the spreadsheet is working. So we have some temperature information. Some places we have a little asterisk next to a quantity, and that will correlate with a little text blurb down underneath that quantity. So HDD, a heating degree day of 1,033, that represents about an average winter month in Holland, Michigan. Some winter months are colder, some are warmer. That's about an average December through February month. What that correlates to is an outside temperature of 30.6 degrees Fahrenheit. So we're going to simulate an average month, so we'll use it 30.6 degrees Fahrenheit as our outside temperature. The inside temperature we're going to use is a design temperature. So it's not the actual temperature inside your home, but a design temp. The actual temperature of your home is going to be a little bit higher because things like people, lights, appliances, TVs, all of those types of things actually raise the temperature because they're also generating heat. So this is a design temperature because it's looking simply at the heating system of the home, how much energy does it need to provide. And then some of those other activities inside the home will raise it up to what the temperature actually is going to be, which is maybe more like 70 degrees. Over here, we have some air properties and things about convection. So convection, right, is the process where heat goes from, say, the middle of the room actually out to the walls, or from the wall exterior out to far away from the home to the outside. So that's going to be an important piece of our heat transfer process that we're simulating over here. Down here at the bottom, there are a few more tables of information that will be helpful to us. This one on the left is about material insulation values. So these are our MFG values for a lot of different types of materials. Here at the top, we have our MFG values, for example, for drywall, vinyl siding, storm windows, a double pane window, different things that we might find in our home. Down here at the bottom, we have our MFG values for a few different types of materials that we could find in our home, but in different thicknesses. So something like a cellulose insulation, a blown cellulose insulation, we would expect 1 inch thick to provide an R value of 3.5. But if we had 2 inches, that should provide an R value of 7. So these are going to be things that maybe we'll find in different thicknesses like wood, cellulose, and our spray foam insulation. The last thing I want to draw your attention to is this weather sealing savings. And to talk about that, I need to introduce you to the concept of air changes per hour. So in this section of our spreadsheet, we're looking at air infiltration calculations. So air is going to be coming from the outside into our home, around the foundation, through where the roof connects to the rest of the house, windows, leaky windows, doors, kind of you name it. If air can get in, it will. And we quantify that with the number of air changes per hour. So what that means is we have a baseline case, so that's the house as it currently is standing, has a number of air changes per hour of 1.4. There are going to be different things that we can do to reduce that, but what a value of 1.4 means is it means in 1 hour, we have 1.4 times the amount of air coming into the house as the volume of the house. Okay, so what does that mean? Well, if our air changes per hour value were 0.5, that would mean we could calculate the volume of the interior of our house, and it would take 2 hours for that volume of air to leak inside. That would be actually a pretty good value. I know it seems like a big number, but we actually do want fresh air. So it's actually really important for a home to not feel like there's kind of old, stale air inside. Maybe you've been in a home or a space like that. The American Society of Heating and Refrigeration and Air Conditioning Engineers, ASHRAE, thinks about these types of things, and they recommend a minimum air changes per hour of 0.35 to provide sufficient fresh air for most homes. There are different standards for different types of spaces, but for a residential home, about 0.35 air changes per hour is typically sufficient for there to be enough fresh air for you to feel comfortable. There are different things. So 0.35 is the low end of what we want. We don't want to go below that. But we're maybe at 1.4 in a place like Pole Cottage. So there are lots of different interventions that we can do to help to seal the home better. So in this table down here, we see a bunch of different types of weather sealing estimates, basically anything that we can do, whether we're adding insulation or specifically sealing up leaks and cracks in the home, that's going to be able to reduce the number of air changes per hour by some amount shown here on the right. So we're going to be looking at that as well. Then here in the middle of our spreadsheet, this section here in the middle, if you look across a single row, maybe let's look across the attic here, we can see this is basically a piece of calculations that we've done in lab before. So we can see the dimensions of our space, the number of feet squared, 1272 feet squared. We can see the current insulation value, R19 insulation. That's what's currently in the cottage. Here we have the RMFG of the entire wall section. So this is the insulation value plus the value of the rest of the wall, which in this case is the drywall down here. Then we have RMFG total. So we have the wall section, but we also have convection. So that's what this is taking into account. So this is taking into account both the wall section here, the 19.5, but then it's also taking into account these two convection processes from the inside space up to the wall, and then from the exterior of the wall out to the outside. Those two convection processes. Then last, we are calculating the amount of heat transfer, the area, times the difference in temperature up here, divided by our RMFG value. And last, we're doing a unit conversion to find the from BTUs per hour to the number of therms that we would see in a given month. We do that across all different areas of our home. So how it's organized, we first look at the top and bottom, the floor and roof. Then we look at doors and windows, and then we look at the exterior walls, and last we look at these air infiltration calculations. Each of those we're calculating the amount of heat for each of these different processes, and then at the very end, adding all of that up into the total amount of heat here in green. So that's basically how the spreadsheet works. I know that was quite a bit to follow. What we're going to do next is start with a relatively blank spreadsheet, and we're going to fill in the information for Pole Cottage.